in chemistry. I'm just finished my regular exercise. Okay, and it's very fun, it's very enjoyable, okay, for maintaining the good health, maintaining a good immune system. Now I have to discuss another topic at this moment in time. Actually, this is related to the equilibrium decision of molecules or basic solution or acidic solution, but this is a very so when we talk about the rate of reaction, okay, when we talk about the rate of reaction, it must obey again the steady state chemical reaction that obeys primarily or significantly the law of conservation of mass or law of conservation of energy. Okay, guys, chemistry just is always like that, obeying the law of conservation of mass and law of conservation of energy. It's just the same, okay? So in chemistry, it's very important that we can have an idea to protect the products out from the reactants. And of course, are to be well versed in the different types of chemical reactions that had been discussed a long time ago. Okay, I've already discussed, right, the 5 types of chemical reactions. So every chemical reactions all over the world and in the entire universe is always be on that type of that chemical reaction. It cannot escape. Okay, because for example, if I have the photosynthesis chemical reaction in which it involves light energy of the sun, so from chemical energy to, okay, to convert that by the presence of the light energy like that and produce energy that we use every day, okay, or the kinetic energy. Okay, when you receive the energy from the food, okay, normally we can do our task in our work. Okay, we can do things. For example, we can dance, we can sing, or me like this in front of you, I'm talking. Okay, I can do whatever because I receive energy. So those energy or that energy is coming from the reaction of photosynthesis, in which the reactants are coming from the chlorophyll from the plants. Okay, so in short, we will not live without the plants. Plants made us alive because 90% of the plants are food. Okay, we will survive through that. So there are chlorophyll, the green pigment, okay, and then it was being analyzed in the laboratory, okay, by using the spectrophotometer. Okay, meaning the contents of chlorophyll, okay, the empirical form of chlorophyll talk too fast, just signal me. All right, Sotero or eternal voice and singer, just slow down because you're talking too fast. Okay, don't worry. Okay, anyway, my English is very clear, right? Okay, though I speak clearly to anybody, guys, right now. So, as much as possible, I will enunciate words clearly and properly that you understand. Okay, never mind. Okay, with the grammar because we are not vlogging and live streaming with the grammar here. Okay, like that. The important is you know the information behind what I am discussing. Okay, like that. Okay, so this is very important. I have to talk another topic which is okay. By the way, I talk too much, but I did not mention to you the topic that I'll be able to discuss, right? So this is really a proof and evidence that I'm talking to you on the spot. Okay, I did not prepare, I did not, I didn't memorize what to talk. This is spontaneous and this is very extemporaneous. Okay, the title and the topic of this vlogging or live streaming is all about Lee Chatelier's principle. Okay, who is that Chatelier? Okay, that is Louis Henry. Okay, Chatelier. He is a scientist in 1901. Okay, like he is very intelligent, but there was problem after the result of his experiment. It was exploded, something like that, and then his assistant was dying due to that explosion. And there's an issue for that. After that, there was another evolution of discovery, and scientific discovery by Mr. Haber. Haber process, okay? He tried to prove the failure of that low Henry Chatelier, okay? But he is still using also the theories and principles that are taken from the Lois Henry Chatelier. So it's still there. Okay, this Haber still apply the basic theory of the experiment and scientific research from Lois Henry Chatelier. Okay, he is also basing there. But this Haber process is a little bit successful because there's no explosion behind that. And then his study of scientific research boost, more production. It helps a lot in the economy because his discovery is the production of ammonia. Okay, the production of ammonia, the reaction of hydrogen gas plus nitrogen gas to produce ammonia. And this ammonia is commercially sold all over the world until now. Okay, the basic concept in the scientific research and discovery is originally coming from Mr. Haber process. So this ammonia is very important in the production of industrial fertilizers also in growing up our plants so that we can have a lot of food. Okay, so Mr. Haber process is we should be thankful to him. Okay, because in him there's a production of ammonia, and ammonia is used in fertilizer, something like that. And our plants will not grow without fertilizers. Okay, not only that, another different chemical process industries that uses ammonia as a raw material. There's a lot. That, right? I think so. Okay. But his basic scientific discovery or research is all about the production of ammonia, which is very successful. Okay, take note. His production of ammonia discovery, okay, involves a temperature of 200 degrees Celsius to 450 degrees Celsius. So the limitation and restriction to his kind of discovery, because less than 200 and above 450, he cannot produce an enough and adequate production of ammonia, something like that. So the reaction in producing this ammonia is very important to discuss the Le Chatelier's principle. Okay, like that. Okay, and another example also is we need to go back to the single displacement. No, it's not single displacement in chemical reaction. That is double displacement and double replacement reaction, if you can remember that one. Okay, we will try to take two examples only. Okay, the double replacement and double replacement, double displacement chemical reaction, and the ammonia reaction by Mr. Haber. That is called Haber process. Okay, so this is in chemistry. Okay, like that. Oh my gosh, it was interrupted. Sorry for a while. Okay, don't you worry, it will come back. My God. Okay, guys, I am here. This is Professor Engineer Sotero Nepomuceno Jr. I am a senior eternal voice. Okay, hello guys. How are you doing? Stay safe. Oh my gosh. Okay. Again, I have to introduce my real name because I'm always do the vloggings and live streamings without introducing my real name. Actually, I am Engineer Sotero Nepomuceno Jr., a graduate of BS Chemical Engineering Institute of Technology University. Okay, like that. And then I have also trainings in occupational safety and health, and my profession and my career now is occupational safety and health. Okay, like that. Okay, going back to the topic, which is the Le Chatelier's principle. Okay, what do you understand of this principle? There's a lot of principles in chemistry, as you can remember, right? We have the Archimedes principle, we have the Arrhenius theory, we have the theory of relativity of Albert Einstein, the theory of Isaac Newton, the three laws of motion. Okay, the theory of Clapeyron of ideal gases. Okay, remember that one? Emile Clapeyron in 1834, ideal gases. And we have also the theory of radioactivity by Henry Becquerel. You remember that one also? And radiation by Pierre Marie Curie. discovered radioactivity or radiation, something like that, if you can still remember for that. Correct me if I'm wrong, but that's basically the thing like that also. We have also the discovery of the, by Charles Goodyear, the vulcanization of rubber, something like that. It's still part of chemistry also. Okay, and then Alexander Fleming, the discovery of the penicillin, okay, the discovery of oxygen by Jules Priestley, the discovery of hydrogen by Henry Cavendish, and a whole lot more in chemistry. So those scientists you have to remember always also, because whether the examination is difficult or simple, there must always be like that. Blanc is a scientist who discovered blah blah so and so, like this. Okay, and you have to carefully take note that one also. You don't have to memorize, but you have to understand what their discovery all about. Okay, you can determine your last name only, like that. Okay, because last name is more good, because in the choices, for example, if the examination is multiple choice, the last name will be there always. Okay, like that. For example, who formulated the formula E is equals to mc squared, where E is equals to the energy, m is equals to the mass of the object, c is the speed of light, which is 3 times 10 to the 8 meter per second. A, like that, Henry Cavendish. B, Pierre Marie Curie. C, Albert Einstein. D, none of the above. So your answer will be letter C, Albert Einstein. Because Albert Einstein's discovery is more on energy. And then if you could relate that also to the energy in ideal gas law also, then we have also the formula. That one is to equate two formulas. Okay, like the energy in ideal gas law will be equal to 3 halves. Number of moles times R times T. R is the universal gas constant, something like that. All you have to do is to master the formulas and memorize it, and then understand why it become like that, and then write and rewrite, in a piece of paper, and then you can memorize that. And I will tell you, it will retain to your brain until your last breath. Okay, when you go 50 years old, 60 years old, 70 years old, still you're in your brain, that you cannot forget that density is equals to mass over volume, even though you are now very tired, you're very old like that, and you need to see the Lord our God because you want to be, you want to rest, all right, because you're very old. Then you still remember that chemistry is still in your brain, something like that. Okay, the Haber, going back to the Haber process, we have the nitrogen gas plus hydrogen gas equals to ammonia. A stoichiometric relationships of each amount of number of moles so that we can balance the chemical reaction before we can proceed to the discussion of this Lee-Chatelier's principle. This Lee-Chatelier's principle is more on theory. It's not more on problem solving, that you will understand the chemical reaction. In a steady state chemical reaction, there is an equilibrium, the balance of the chemical reaction, the forward of the reaction, and the reverse reaction must be balanced. Okay, the rate of the forward reaction must be equal to the rate of the backward reaction. The reverse reaction, that is steady state reaction. If it is not balanced, then it is not undergoing in the equilibrium stage. So you cannot compute what you are requiring for, except the number of moles, the number of grams, the number of concentrations of the products and reactants, something like that. And still, you have to take note of the different variables, the physical properties, right? The volume, the temperature, the pressure, okay? And then you have also to consider the concentration, something like that. Or any other physical properties. It could be boiling point, freezing point, melting point. Okay, something, there's a lot to explain, but we cannot explain that all of you because I am not also well versed in everything. Okay, just a few I learned, so I cannot discuss to you everything about that also. Okay, it's limited discussion only, specifically to Lee-Chatelier's principle. I'll show you the chemical reaction of the production of ammonia comes from nitrogen gas plus hydrogen gas. Okay, woo! Okay, wait. Okay, sorry for that. Okay, really? Okay, if you're students now, alert. please listen to me right now. If you're a high school, a senior high school student, you have chemistry, then listen to me now. It could help you a lot also. And if you have modules now in your home, then you can also listen to me a little bit. And you can also compare to my information that you've obtained from my discussion, something like that. And somewhere along the way also, you have to understand also what I'm talking to, then you have to correct me if I'm wrong, like that, because all persons are subject to imperfection. There's no perfect in this contemporary world, because if you will not accept flaws, mistakes, errors, then you are not a competent person. If you are a professional and competent person, you have to acknowledge your errors, restrictions, limitations, weaknesses, and errors, blah, 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 chuva, chu. Okay, like that. And after this vlogging or live streaming, actually this is live streaming, right? Okay, this is really live streaming, not vlogging. Sorry for that. After that one, I have to issue an error statements in the description of this video. Okay, that is gonna be my mistake like this, and I correct that. Okay, normally I do that, right? Because in my discussion before, on the spot solving problems, then I may be wrong in some areas, and I have to review that in order I can obtain the correct answer. That's gonna be like that always, okay? To have actual and on-the-spot vlogging or live streaming, okay? I don't want, prepared and scripted, because if you are doing that scripted and prepared vlogging and live streaming, then you are automatically perfect in all your discussion in your virtual audiences. It's not like that. We should have an interactive, reaction between each other. Oh, that's wrong. Correct me. And okay, like that. We have to share ideas. That's why we have brainstorming. Okay, like that. Okay, the more ideas, the better, because more heads are better than one. Okay, something like that. Okay, so we need to accept ideas from others who knows they have ideas that are very good compared to you and you did not know yet, and then they also learn from you. Is a symbiosis relationship, give and take relationship in the biology, as you can remember that one. Okay, stand-alone discussion. We have to interact with each other. So this is an interactive platform of discussion in YT live streaming. This is in the house. I am a singer, eternal voice, Sotero. Okay, going back to the chemical reaction, I have to find scratch paper for that. Okay, my gosh. Okay. Okay, this is it. I am very, very busy making videos, live streamings, vloggings, because I want my viewers to intensify, okay, to be enhanced and augmented. Oh my gosh, to be augmented to reach the requirement of YT administrator, something like that. And hopefully, guys, I will be now monetized. Okay, pray for me. Okay, there will be no problem during the evaluation of the YT administrator regarding my YT channel. And as much as possible, I obey the requirements so that I could be monetized someday. Woo! Bingo! Like that, I'm almost there. Thank you, Lord. Thank you so much for everything. Thank you also for my audiences who listen like me. If there's nobody listening, then I'm not here right now, right? So even though the viewers are not so high, but at least you are still alive and sharing information to like that to all of you guys, something like that. Okay, going back to the reaction, so that I can explain clearly what is sorry. My voice is so, strong, right? My voice is too strong, right? Because I just did my exercise and I'm very, very energetic and alive. Okay, something like that. Because it is, it is complementary. If your physical aspects have been exercised, you have do stretching, everything, and then your brain also stretching and energy, because it's really complementary everything in our body system and the anatomy of our body, except for the liver, the heart, the brain, the intestines, the feet, the foot, the external and the internal body parts of a human being are always complementary with each other. That's why I'm very, very happy now to do the live streaming. As you can see, my mouth is very spontaneous, talking to you so much, something like that, because it was energized also, because my body parts are also trainer, so I did exercise and stretching, and I'm very, very happy to that. Okay, bingo. Okay, going back to the reaction, chemical reaction of the Haber process. Okay, like that. Just sir, take slow, like that, because my English is very fast. Maybe you cannot understand. Okay, but you know, if I'm very slow also, I cannot, go to the next, okay, terminologies or information that I'm going to share with you. So I will be stagnant. That's why I'm talking very, verbatim, spontaneous and extemporaneous. Okay, because I love English so much, and everybody knows about that because I already confessed that a while ago. Okay, like that. Because my first favorite really subject is English. Okay, like that, because I want to become a broadcast journalist when I was in high school, but due to my academic scholarship, it's not being there, so I forced to take up chemical engineering because I love pure sciences, something like that. Okay, there's a scratch paper, but this is a very clean paper. I have to consult this, right? Oh my gosh. Oh, this is a problem. What is the composition of ink? The chemical composition of ink. Anybody knows? Okay, I have to research for that because if you like the pencil pen here, it will also be shown at the back. No good. Okay, so I cannot save the paper. Okay, like that. And we have to conserve energy resources as part of the, advocacy of an environmentalist. Oh my gosh. So all of us must treat ourselves as an environmentalist to help nurture and care an environment because the future of our children depends on the situation right now. We should not abuse the creation of God. So through that, we need to be environmentalists and we have to conserve energy resources. Not only that, we should be responsible also by not throwing our wastes anywhere, something like that, so that we could not have any pollution in our environment. Okay, we can minimize, though we can stop, but at least we can minimize. So we can only do that to be a responsible environmentalists by our own selves. No need to teach, no need to guide, no need to force. Be responsible enough and be disciplined with ourselves, something like that. Okay? Because we need to love, nurture, and care an environment that God given to us freely so that we can survive, something like that. Okay? That's it. Going back to the Haber process or the production of ammonia. My gosh. Hello guys, I will just take my coffee first before. Oh! Coffee first because coffee has caffeine and it will energize your brain cells, something like that. But sometimes if you drink too much also you will not feel sleepy. That's why I will drink coffee for that reason. So that I can survive for this live streaming. Okay. Time check. Okay. Oh, I still have more time. Okay, stay with me guys. Shout out to my fans out there, my viewers, okay, in all my social media platforms, in Twitter, okay, in Facebook. I have 2 Facebook accounts and my Instagram also. Okay, thank you so much. Thank you so much for all my friends there in all my social media platforms. Okay, thank you so much for watching now, for sharing your time with me. I know you are very, very busy guys. Especially nowadays, we have a pandemic problem with coronavirus, and so stress in our mind and everything, and then you still spare your time with me, okay? Just stay tuned, okay? I'll be able to drink coffee, okay, guys? Okay, I'm here. I'm just here. Okay. Like that. Water is life. Okay. Water alone is, we can discuss a little bit water. Water is very broad. We can discuss because everything comes from water, very important in our survival. Okay. Water. Our body composed of 75% of water. Okay. Like that, and the earth or the world composed of 75% also of water. So it's more on water. Okay, it's not more on land. Something like that. Okay, that's why we can survive a little bit if we have drink water every day, even though we will not eat. Okay, because water contains minerals, calcium, magnesium, potassium, chlorides. So those minerals also comprises for the survival of humanity, the body percent of our system, something like that. That's why even though you will not eat and you will Haber process. When I was in high school, really, I think this has not been discussed in college in the general chemistry. This has been discussed, okay? Because in high school is more on, not really that going deeper. It's just only the introduction, something like that. And there's no such complex a lot. But then in college, there's a little bit complex, involving complex problems, theories, and principles behind that. Like, gosh. So, still, the basic knowledge in high school can be used in college. Okay, like that. And there's same, little bit similarities, especially for the basic concepts and theories. Okay, but I don't think so. I could not remember because that's too long. Okay, that's 28 years ago. Not 28 years ago. 25 years ago in my high school. I could not still remember if my mentors and teachers are discussing this in front of me or in front of our classmates. Oh my gosh. Okay, I think they did it, but I'm just, sleeping or whatever. I'm just talking to my classmates. I did not hear very well what that topic all about. Okay, because I am very young at that time. Okay, usually when we are very young, we are not really serious about subjects like this academic subjects. We are just only studying just to pass, and we did not know that there is more relevance for that we'll be able to use in our everyday life, like that, in our work in the future, like that. So our minds are very young. It's not really that matured enough. Okay, that's why we cannot remember if our teachers are discussing these particular topics like this, blah blah blah, so on and so. Okay. Oh, it's already boiled. Already boiled. So the boiling point has been reached, 100 degrees Celsius. The vapor pressure of the liquid will be equal to the pressure of the surrounding. So it has attained the boiling point. Okay? That's the definition of the boiling point. There's also an equilibrium of the vapor pressure of the liquid, which is the water, and the pressure of the liquid surroundings. Okay, or liquid surroundings, right? Surrounding of the liquid, it's just the same. Okay, so if it is equal, it's established an equilibrium there, and the boiling point will be achieved. Then 100 degrees Celsius. Now you can have the water that is being boiled, and you can have now your coffee. So this is still chemistry, right? Okay, my gosh. Okay, like that. Okay, guys, I will be back. I'm just, trying to make my coffee. Oh my gosh. Hello world, hello Philippines, hello world, hello Philippines. My orange is ready. Okay, ready. My orange is very ready. Okay. This is ascorbic acid or vitamin C. You still remember the formula for this? This is 6 atoms of carbon, 8 atoms of hydrogen, and 6 atoms of oxygen. Okay, the hydrogen ion, which is the H+, will try to react the polyatomic ion CHO. Okay, we have the CHO, C6H7O6, like that. Raised to the power -1. Okay, so that is ascorbate. Ascorbate again, C6H7O6 raised to the power -1. Okay, so this ascorbate will react to the hydrogen, which is a charge of +1, and they will click with each other as a one compound. Then it is called ascorbic acid. So ascorbic acid is what we call as vitamin C. Without vitamin C, we will die in this world. Because vitamin C has full of antioxidants that will try to protect our cells from any bacteria, viruses, bad microorganisms, will try to destroy our cells and tissues in our system, in our internal body system, and then we will get sick. and we will be suffering from any cancerous diseases or whatever. So all pathogenic substances will be prevented to accumulate in our body system through this vitamin C or ascorbic acid. Okay, like that. So ascorbic acid, though it is an acid, but this is very, very essential for our survival here in the contemporary world. Something like that. I prefer the fresh juice or the fresh vitamin C of the orange as I have in my hand now compared to the multivitamins, because we don't know multivitamins have also side effects in our other organs in our body. So this is more safer, the fresh orange. Okay, this one. Orange. Okay, the juice is very important like that. Okay, so this also belongs to, we need this, we can get ascorbic acid vitamin C through citrus fruits. Okay, citrus fruits. Okay, so again, orange, lemon, apple, calamansi juice, like this, and other fruits and other vegetables, also green leafy vegetables, have vitamin C and antioxidants. Okay, like that. And the citrus fruits have a citric acid originally found in the fruit, like this. So what is the formula of citric acid? Oh my gosh, you forget already. So C6H7O6. Okay, the hydrogen ion H plus will react to the citrate. Okay, remember that one. Most of the polyatomic ions will end in ATE. Okay, ATE, ate. So it's about citrate. Okay, like that. Ascorbate. Okay, phosphate, silicate, manganate. Okay, oxalate. So ATE. That is the rule of polyatomic ion. Okay, like that. And this polyatomic ion, citrate, okay, will react to H, will become citric acid. So what is citrate? The exponent is not -1, but -3, like that. Okay, C6, like that, H5O6, -3. Okay, C6, H5, okay, O7, -3. Okay, so 657, like that. Just remember, 657 and -3. Okay, then if you try to react with H, so it will become C6H7O6. Okay, something like that. Okay, C6H7O6. Okay, like that. Correct me if I'm wrong, because it is very technical. Okay, like that. Again, this I'm telling you every time, correct me if I'm wrong, it's very technical, right? C6H8O7. Okay. I will write, okay, so that you will remember this one. This is very basic, right? So C6H8O7. Just remember this one, C6H8O7. So what's that? This is citric acid. Citric acid comes from the citrus fruits that we try to most of the times to gain vitamin. Okay, because this citric acid will react to water that forms vitamin C. Okay, like that. You understand? Though the citrus fruits has its original vitamin C by nature, but if you add water, still there is a production of ascorbic acid, sorry, acetic acid. Okay, sorry for that. There's so many acids, I mentioned acetic acid, why that? What comes to my mind? Okay. Acetic acid, by the way, is a weak acid. That is a vinegar. Okay? Acetic acid is a vinegar that we use in our cooking. Because I mentioned that now, right? It comes in my brain. I did plan that to mention right now. It comes to my brain. Acetic acid is a vinegar, okay, that we use in our home. It's acetic acid, okay, C2H3O2. 2 atoms of carbon, 3 atoms of hydrogen, and 2 atoms of oxygen raised to the power -1. Acetate. Remember, ATE, acetate plus H plus clip together, so it becomes an acid. Okay? Neutralization reaction between the charges, positive charge particle and the negatively charged particle, or the ion, something like that. Okay, remember I discussed that already a while ago. Okay, like that. So this is the citric acid. Okay, this one. Just remember this because every time you will eat apple, okay, banana also have, I think so have, only little bit. But banana is more on potassium, magnesium like that. But there's a little bit of citric, I think so. But the orange, the lemon, the apple, the calamansi has more rich in citric acid. Okay, C6H8O7. Okay, like that. So the citrate will be, just remember this one, C6H5O7. It's negative 3. Okay? C6, take a look. C6H5O7 negative 3. Okay, when it react to the hydrogen, it will become C6H8O7. Okay? Unlike the ascorbic acid or ascorbate polyatomic ion is only negative 1. That's ascorbic acid something. There's a lot of acid, I already mentioned that a while ago, right? There's a lot. Linoleic acid, oleic acid, chloric acid, oxalic acid, ascorbic acid, citric acid, okay, stearic acid, butanoic acid, butyric acid. There's a lot of acids, and you should know every properties of that acids because in every examination there's a lot also questions like that. Okay, for example, okay, and there's a lot of acids you cannot guess. Okay, but the answer is hydrochloric acid. Okay, there will be a lot of choices: A, HCl, B, sulfuric acid, C, phosphoric acid, D, sulfuric acid. And the answer will be hydrochloric acid because that is the natural acid we have in our digestive system. Okay, like that. Need to remember those acids, by the way. Could it be weak acid or strong acids, organic acid, something like that? Blah, 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 choo, choo, choo. Okay? What happens to my coffee now? Tagal ko nagsisimula sa ano, let's response to what's happening with me. Okay? Oh my gosh, I have so many, utensils to be washed. Wait for a while. I have to wash this first because how can I drink the coffee? There's no utensils. Okay. Hello guys. I will reboil again because I don't want that the water will be cold. I want a very hot coffee. Oh my gosh. Stay with me. Oh my gosh. Again. Sorry. Are you still there? I am here waiting for I revolve the water. Okay. Coffee for life. Gosh. Oh. Hello everybody, hello world. Welcome to a live streaming regarding okay. If you remember Facebook account, there is an introduction in my profile, Lee Chatelier principle, okay? Because I love that principle, my gosh. Okay, we'll never forget this principle. Okay, so what is the definition? Let's go first to the definition of Lee Chatelier's principle. Anybody? Okay, anybody? So Lee Chatelier principle, okay, whenever a stress is applied to the system of equilibrium, okay, equilibrium will shift, okay, in some way to reduce the stress. It's very difficult to understand the terminology. We have to explain that further through a big and common sense explanation. And the stresses are talking about the variables which are the concentration, the pressure, okay, the volume, and the temperature. Okay, this is the time that we will be able to account the two types of energy reaction, which is the exothermic reaction and the endothermic reaction. Okay, as you can recall in your high school chemistry, endothermic reaction consumes heat. It consumes heat. The process will be on the colder side. Okay, because the heat are being consumed, so it is expected that the environment is already cold because there's no heat available in the surrounding. It's common sense. That's endothermic reaction, and in that also, it is if it is very cold, then the temperature will be lowered. Okay, because the surrounder is cold. Okay, like that. In exothermic reaction, there will be a release of heat. Okay, when it releases heat, what will happen to the surrounding? It is very hot, and it is expected that there will be a rise in temperature by common sense. The more you will release heat too much, the more it will become hotter, and the more the temperature will rise. Okay, no need to go in some books that's already theory and by common sense. Okay, like this, the coffee is very hot in my hand. Okay, so there is exothermic reaction because the heat is being released here. Okay, I cannot hold properly this hotter environment, something like that. But in this glass, but the outside may be cold because I ordered AC a while ago, but it's still not enough to compensate the hotter surface. The AC are already off. Okay, so the will no longer balance. Ganun ba yun? Okay. Should be balanced to achieve equilibrium. Okay, like this. In here, there's an exothermic reaction because it's a hotter surface of the gas and the water surface. Okay, the coffee surface, by the way, the mixture of coffee and water. Okay, there's an exothermic reaction and endothermic reaction, temperature like this, pressure, concentration, and volume. So these are the stress referred to that definition. Whenever a stress, okay, for example, pressure, whenever a pressure is applied to a system of equilibrium, the equilibrium will shift. You have to just substitute the variable I mentioned. For example, concentration. Whenever a concentration is applied to a system of equilibrium, blah, blah, blah. Whenever an exothermic reaction is applied to a system of equilibrium, because these are all stresses. So the stress here referred to these variables that can affect the equilibrium, where to shift the reaction. If you try to add or decrease this variables, it will shift to the left of our reaction. If we add something, if we add more concentration of this blah blah blah, it will go to the left with the reaction or not, something like that. This is not more on problem solving. Okay, like this. But you can also apply that in the problem solving during analysis only. This is gonna be greater than this because you know the initial number of moles will be like this. Okay, but not really that because this is more theoretical. Okay, more on concept. Okay, that you will be applying in the complex topics in higher chemistry, something like that, or especially in kinetics. You know kinetics, chemical reaction engineering that deals with chemical reactors, the rate of reaction, blah blah blah, in the reactant and the product. So like this will be helpful, the Chatelier principle, okay? Because it talks about the rate of reaction, the forward reaction, the backward, the reverse reaction, something like that. Okay. There are also other things to be remembered that, for example, the catalyst, you know, catalyst, and the inhibitor. But these are not affecting the equilibrium, but this must be mentioned also because there are a lot of chemical reactions that needs a catalyst in order to speed up the reaction. The reaction is very weak and we need to add a catalyst, something like that, especially in the process, in the manufacturing process, or whatever, For example, again, going back to Haber process, okay, the catalyst is being introduced, there is iron. Without iron, the rate of reaction of nitrogen and hydrogen will not be fast. It will not produce more ammonia. in the product, something like that. So catalysts will also matter in a chemical reaction, but not affecting the system of equilibrium. Okay, but still it's necessary for the chemical reaction, or else it will be the way. So we should consider it also catalyst and an inhibitor. An inhibitor is the opposite of the catalyst. This inhibitor will slow down the rate of the reaction. Could it be a forward rate of reaction, or could it be a reverse or backward reaction, something like that. Okay, it's always be inhibitor and catalysts. But it's more on catalyst because it speed up the reaction. Okay, especially in a manufacturing plant, process plants, or power plants. There's a lot of catalysts there. I know that. Though it's not specific, but generally have catalysts there. Okay, and catalysts are also very expensive. You have to analyze very well if it is really suitable to the type of chemical reaction, or else it will be a loss of money if you buy those catalysts and are not suited or not capable of speeding up the rate of reaction. It's really useless, right? Okay, you have to study also the parameters of those catalysts before you introduce and you add that to your chemical reaction in the process. Okay, something like that. Oh my god, very hot. Very hot coffee. Oh, I love that the aroma is very delicious. Delicious. Delicious or pleasant? Oh my gosh. I'm feeling the coffee aroma because I did not put sugar. The more you will not put sugar, the more you will taste, or you will grasp the aroma. Diyan naman tayo, grasp. What's grasp? Absorb, like this. Oh my gosh, very delicious. Oh, my stomach is getting hotter. Okay. Oh. My gosh, wait for a while. Hello guys! Hello everybody! I'm back drinking my coffee. My gosh. Okay, let's go back to business. Okay, we have now the ammonia. Okay, production of ammonia first. Okay, so before understanding further, we need to have a hypothetical symbol to further interpret. For example, A plus B is equals to C, like this. This is more on the synthesis reaction and a combination reaction. This is a Haber process, okay? Because you add A and B to produce C, okay? And we try to relate the nitrogen and hydrogen gas to produce ammonia. It's gonna be like this. Nitrogen gas plus H2 gas is equals to ammonia. Oh my gosh, am I gonna learn? Okay. A and 2, B, H2. C is ammonia, like this. But this, the bottom is not yet balanced. We have to balance first. Okay. Everything here you have to balance, okay? You cannot proceed further if you will not balance the chemical reaction, or else you will be wrong in your computation or calculation. Okay, nitrogen, 2, and then the other one is nothing, so you have to put 2, like this. Okay, 2. Hydrogen, 2. Hydrogen, 6. X, 2x. X is equals to 3. 3, like this. Okay, like that. So our final and balanced chemical equation will be like this, and gas is equals to 2 moles of ammonia. So there are 6 atoms of hydrogen in the reactant, and there is also 6 atoms of hydrogen in the product, and there is also 2 atoms of nitrogen in the reactant, and there is also 2 atoms of nitrogen in the product. So it is completely B plus C. So like this only. So 3. right? So 3B and then 2. So A plus 3B plus 2C, like this. For hypothetical chemical equation for the purpose of discussion only. Okay, like this. Like that. Now, going to the Chatellier's principle, we go first to the pressure. Okay, pressure. Okay. If we have a beaker, you know a beaker in the laboratory or a flask utensil, okay? A glass laboratory utensil or whatever, or metallic, okay? Like this. For example, I have this, a glass, a beaker, something like this. I will draw this one. We go first to the first stress, which is the pressure. The four I mentioned, right? Pressure, concentration, like this, temperature, exothermic reaction, Berger reaction, okay, volume. Five pala siya. Okay? Like that. This one. Okay. First, we go to the increase. If we increase the pressure of hydrogen gas, what will happen to the reaction? In what manner it will go to shift? In the what direction? So this is about direction of shifting, the Chatellier's principle. Okay, so if we increase the pressure, so we increase the pressure, I will draw here, increase meaning arrow up, right, in illustration. So increase the pressure, arrow up. So if the pressure, if there's water here, okay, like this is the water, okay, this is the water, the transparent one. And there's a lot of molecules like this. I will show you the molecules like this. Okay. Molecules of water. Or molecules or particles is just the same in definition. Huh? Molecules or particles. Okay. Here, the molecules of liquid has its own solubility like that. Okay. Remember that Henry's law? And then there is intermolecular forces with each other. Okay, like that. So it will collide with each other, something like this. So the more you add pressure, the volume will become lesser. Okay, the volume will become lesser. So when the volume will become lesser, okay, common sense, when the volume become lesser, the space will not be adequate enough. The space is limited. Okay, what will happen to the molecules? The molecules or particles cannot move too fast. Okay, because they are hindered with the space. They cannot move freely. They cannot collide freely because the space or the volume is lowered, something like that. Okay, so automatically the number of moles will be less. Okay, in here, moles. So the number of moles will be less. Okay, number n. Let's represent the number of moles as usual, a small letter n, right? N will be less, something like that. Less. Okay, in here. Okay, n is the number of moles. Okay. Blank, going back to the question, blank is the unit of substance. Okay, the answer will be mole. Okay, as simple as that. Okay, because it's very simple in chemistry. Okay, like this. So n is the unit of a substance. This is a mole. The number of moles will be lesser because there's a little space for the molecules and particles of the liquid to move because you apply too much pressure and the pressure is high and your volume will be lesser. Okay, like that. Okay, if you apply high pressure to hydrogen gas, okay, it will shift to the lower number of moles basing on this illustration. Okay, because I explained the higher pressure, right? So this equilibrium, this equation will shift the hydrogen, will shift the reaction to the ammonia because ammonia has only 2 number of moles compared to the hydrogen, which is 3 moles of hydrogen, basing on the explanation of this water that is applied pressure, blah, blah, blah. And the reverse will holds through. If you decrease the pressure of hydrogen gas, will shift to the right or the reactant. Okay, because there is higher number of moles. The reverse of this discussion. If you try to push something like that, and there's a higher space, there's no restriction, and the more particles on molecules of the liquid will move with each other. So there's a lot of number of moles. So the number of moles will be higher or more. So if you decrease the pressure, okay, like that, the volume will be goes higher, and then the number of moles will be more. Okay, so the side where there are a lot of number of moles. In this case, the reactant has so many number of moles compared to the product. Okay. Again, Le Chatelier's principle, it doesn't matter to number of atoms. He matters on number of moles. Again, number of moles, because if you try to account the atoms, okay, the atoms are balanced. So there's no reason at all where the reaction will shift. Okay, so this is all about the number of moles. Okay, like that. Okay, very clear. If you apply higher pressure, the volume will be lesser, and there's a little space for the molecules of the gases to move freely. Okay, the number of moles will be less. If you decrease the pressure, the volume will become high, and there's enough space for the molecules of liquids to move freely, and then the number of moles will be higher. So if you increase the pressure and the volume will be lesser, okay, the system of equilibrium will shift to the side where there is a lesser number of moles. Okay, if reverse will hold through, if you decrease the pressure and increase the volume, then the system of equilibrium will shift to the side where there are more number of moles. Like that. That's the theory behind. For example, if we apply 40 atmosphere of pressure of nitrogen gas in N2, well, what will our reaction will going be? In what direction our reaction will shift? Okay, our reaction will shift to the product, because only two number of moles like this. Okay, like this. Okay, we are talking about the sum of the number of moles, not only for the individual but the sum. Okay, because the reactant is the sum of two elements of nitrogen and hydrogen. Okay, so this is also tricky, huh? Okay, because this nitrogen gas has no mole, it's only one, right? And this ammonia has two. And you will say, if I will increase the pressure, okay, of N2, you will say automatically that you will shift to the side of N2 because N2 has one mole only. No, it's not, because it's referring to the total number of moles of the reactant. Still, it will shift to the ammonia side where there is only 2 moles of ammonia, because 1 mole of nitrogen gas plus 3 moles of hydrogen gas is equals to 4. So if you increase the pressure, it will never shift the reaction in the reactant or in the right. It goes to the left or in the product. Okay? Something like that. It's all about like this. Very clear for the pressure and the volume and the number of moles like this. Okay? Okay. I think it's very clear. It's self-explanatory, right? And then we go to that's one, pressure, and we go to the concentration. Okay. If we add molar concentrations of ammonia, so reverse, we need to add concentration of ammonia here. Let's say 40 molar of ammonia. I will increase the concentration of ammonia here, okay, like this, 40 molar, example, in the ammonia. Okay, where is our system of equilibrium will shift? Okay, could it be in the right or could it be in the left? Okay, now, by common sense, okay, you add more concentration in ammonia. So the more you add something to an individual person, for example, me, I have my work, and then somebody added me too much work, I will be in stress. Okay? Again, if I am working and I have so many load or tasks in the job, I will be at stress, right? So I need to remove my stress. Okay, so meaning I will release my stress. I will transfer that to other people so that I will not be stressed. That kind of job that will be added. Same as that here. So to reduce the release of ammonia, he will release the stress. So he will give to the reactant, which is N2 and H2. So the system of equilibrium will shift to the reactant because the ammonia will become stressed more because you add too much of concentration of ammonia like this. Overloaded, he became stressed. So the only thing is to share his concentration to other people or in the reactant like that. So if you add 40 molar ammonia concentration, the system of equilibrium will reduce the stress of ammonia, and the stress referring to that is the concentration. Okay? Now, if we decrease, okay, if we decrease the ammonia concentration, what will happen? Decrease. What will happen? So he is not stressed at all because his concentration is already decreased. So in order to balance the equilibrium, he need more concentration. So he will be added more. He will ask for more concentration by himself. So if we decrease the concentration of ammonia, the system of equilibrium will shift to the product side to compensate, okay, the weakness or the less concentration. Okay, like that. Okay? Like that, because he doesn't have enough concentration. So he need to be added more. Of course, the system of equilibrium will shift to his side, something like that. Okay? And then if we add concentration to hydrogen gas, okay, concentration, hydrogen gas, let's say 20 molar. Same principle, okay? So the system of equilibrium will shift to the right or the product. Sorry, left, right or left? Product side. Okay, like that. Okay, because it's very stressed already, you need to share the concentration to ammonia. Okay, like that. If you add more concentration to H2. If you decrease, then the system equilibrium will shift to the side of hydrogen gas because he needs more, something like that. Okay, very clear. Okay, so meaning to say, if you are really stressed, to give it to other people like this, and then if you are more, give to other people, and if you are not yet given a lot of stress, then accept a little bit of stress so that it will be challenging enough to achieve the stable equilibrium. Oh my gosh! Thank you so much, Cypress Respondo, for watching my live streaming. Hello, Dai. Thank you so much. Well, it's all about concentrations, right? And now we go to the third stress, which is the temperature. Okay. Okay. If we add temperature in the reactant, where is our system of equilibrium will shift? Again, if we add temperature to our reactant, where is our system of equilibrium will shift? It will be to the product side or to the reactant side. For example, we increase the temperature of hydrogen, okay, like this. So the system of equilibrium will shift to what side? To the product side or to the reactant side? Something like that. Okay. So you have to think again by using the principles, again by the beaker of a liquid of water here. Okay, normally if you increase the pressure, what will happen to the temperature? Okay, this is a relationship. Okay, if you increase the pressure, what will happen to the temperature? Anybody? My gosh. Okay, how can we prove that? Actually, in my own analysis, that's directly proportional with each other. If you increase the pressure, the temperature also will increase, but the volume will decrease. Let's go back to the ideal gas law, which is PV and RT, and let's prove that one. Why the temperature will also increase if we increase the pressure. Maybe I will be wrong, but let's try it to prove. Okay, like this. Or you can use another formula that's involved temperature and volume. It could be in the Charles law, right? Charles law. But we will use only the PV and RT because it is the most popular used all over the world. Something like this. We need to prove the theory because this is very important in determining where our system of equilibrium will shift, the direction of our reaction will shift, right? If we add the temperature of hydrogen gas or either nitrogen gas, right? Okay. But say we will use this illustration, a liquid of water inside the beaker. Okay, like that. Increasing the pressure and this time increasing the temperature, something like that. But we have to prove the relationship between pressure and temperature first. Okay, we have the PV and RT, ideal gas law, the general gas equation. Okay, PV and RT. Okay, solve the value of pressure. Pressure is equals to nRT over V. Solve the value of temperature. Temperature is equals to PV over NR. Okay. So this is gonna be like this. PV and RT is equals to, if we solve the value of pressure, we have nRT over V. If we solve the value of temperature, it could be PV over NR. Now, try to have a relationship between pressure and temperature. Okay? Like that. In a glass of beaker, you did not touch yet the liquid there. So pressure is not yet moving. Okay? Because you're not, say example, you did not have put pressure yet. So zero pressure. Okay? So in a liquid of water in a beaker, your volume will still be zero, something like that. Okay? Because you did not touch anything, right? Okay? Like that. And what will be left will be the T already. Okay? Like this. So let's cancel the NR, the V, the NR, and the V. What will left? Because you are not still applying pressure initially. So automatically, the number of moles, the universal gas constant, and the volume will be constant. So you have to cancel that one. Because it's constant. It's assumed to be 1. Okay? So what will be left? P is equals to T. Right? If P is equals to T, normally by relationship, it is directly proportional with each other. If you increase the pressure, you also increase the temperature. If you decrease the pressure, you also decrease the pressure. We prove that in this equation by theory. Okay? Because sometimes you will be lost if we memorize. Okay? It's inversely proportional, directly proportional. We have to prove to this one. So the pressure is simply equal to T, the temperature is simply equal to P, assuming initially that we still not yet applying the pressure, okay, in the liquid of water volume, okay, initial state only, zero pressure, like this, blah, 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 not yet started, okay. So we increase the pressure, we increase also the temperature. Now, the same principle with the pressure. If we increase the pressure, if we increase the temperature, we increase the pressure, right? So, the system of equilibrium will shift to the ammonia side or the product side because it has a number of moles. So the same principle because temperature is directly proportional with the pressure. Okay? Same thing will happen. Okay, if you add temperature in the ammonia, what will happen? What will happen to the system of equilibrium? It will shift to the ammonia itself because it has a less number of moles. The same principles with the pressure for the temperature as a stress. So we are done with the pressure, concentration, and the temperature, right? Like that. And now we go to the energy, which is the exothermic reaction and the endothermic reaction. Still again, because if exothermic and endothermic still involves temperature there due to the presence of heat, still be proportional to pressure, I think so. Let's prove. Okay? Siya para di ba? Endothermic reaction, by definition, consumes heat. Meaning, if you consume heat, the surrounding will become cooled. Okay, so it is expected that the temperature will be lesser. Okay, exothermic reaction releases heat, so the environment or the surrounding will become hot. So there's a release of heat. So that it is expected that the temperature will get high. It's same story also with the pressure and temperature that I already discussed, right? So if we increase the temperature, the same thing, we increase the exothermic reaction. Okay, going back to the equation. So if we have an exothermic reaction in the reactant of hydrogen, okay, the equilibrium will shift to ammonia because it has lower number of moles, for the reason that exothermic reaction is directly proportional to temperature and directly proportional also to pressure, complementary with each other. By theory alone, we can determine where our reaction system of equilibrium will shift. Okay, no need to discuss further because it's by theory already. So, meaning to say, the pressure is directly proportional to the temperature and exothermic reaction, then it will have the same shifting of the system of equilibrium. Now, if we add endothermic reaction in the ammonia, what will happen? Meaning, endothermic, small temperature or less temperature. Okay? So, it will shift to the higher number of moles in the reactant in this side. So if the question in the examination will speak, uh, in the Haber process, I will add less temperature in the ammonia where our reaction will shift. A like this, B like this. So the reaction will shift to the reactant side because it has number of moles more. Just remember this, a liquid of water inside the beaker, and applying the relationship pressure, temperature, volume, and exothermic, because these four are the stresses that the Lee-Chatelier's principle are referring to. Again, Lee-Chatelier's principle definition. Whenever a stress is applied to a system of equilibrium, the equilibrium will shift in such a way to reduce the stress. Okay, like that. Okay, very clear already. No need to emphasize more. Okay, like that. And then in this liquid water, okay, we know that the pressure, if say example, going back, if the pressure is higher, the volume will be lesser, right? And then the number of moles will be lesser also because there's less space in order for them to move freely, and the IMF intermolecular forces are less. Okay, and the solubility also are less, of course, because they will not collide with each other, blah blah blah, so and so. Okay, it's very enjoyable there in this inside the beaker like that. And then this obeys Avogadro law. Okay, in which it involves only volume and number of moles. Remember that one, Avogadro law? V1 over N1 is equals to V2 over N2. Okay, assuming that the pressure and temperature is held constant, something like that. Okay, and always remember that 1 mole of an ideal gas in Avogadro law will occupy 22.414 liter of gas space at STP, standard temperature and pressure, in which our temperature will be 0 degrees Celsius and our pressure will be 1 atmosphere all the time. Something like that. Okay, and you know also the values of pressures. We discussed that a while ago, right? So you are now very alert to solve gas problems like this, blah blah blah, so and so. Okay, so the Lee-Chatelier's principle is very easy, right? It's very short, but you need to analyze the manner of the rate of the reaction of the forward reaction and reverse reaction. By the way, going back to the Haber process, nitrogen gas plus 3H2 plus 2NH3. Okay, this is an example of reversible reaction, meaning the reaction of the reactant will always be equal to the rate of the reaction of the product at a steady state equilibrium, something like that. Again, reversible reaction, the rate of the reaction of the forward reaction will be equal to the rate of the backward reaction in a system of equilibrium like this. in a steady state. Okay, steady state meaning equal. Okay, reaction in the reactant side and in the product side. Okay, like that. Reversible reaction. Okay, but there are other chemicals that are not reversible. So in short, what are the two kinds? Okay, what are the two kinds of chemical reactions? So our answer will be reversible reaction and irreversible reaction. But don't be confused with what are the five types of chemical reaction. Okay, first the synthesis, the combination, the decomposition, the combustion, the singular placement and singular displacement, the double displacement, and then the kinds of reaction which is only two, the reversible reaction or the irreversible reaction. Always remember that one. Okay, in irreversible reaction, it will not be like this, huh? That if you reverse, it will not produce the same thing, something like that, because it is not equal the rate of the reaction. So in that manner, that's the time the catalyst will be added, something like that. Okay, something like that. Okay, but here this is a reversible reaction. But a lot will be irreversible because not all will be balanced. That's why we need to solve and calculate in a stoichiometric relationships in the reactants and the product so that we need to balance it. Okay, so most of it are naturally a reversible reaction. Only few are reversible reaction. Meaning reversible reaction pala, complete reaction siya. Something like that. That it will be stabilized immediately in a one single reaction, something like that. But the irreversible, if you have the reactants, it will produce a product, and again, the products will produce byproducts, something like that, and it's very unstable. And the byproducts will produce again another byproduct. This is in the case of petroleum industry. You know, petroleum industry, the crude oil. Okay, because after that one, after the several processes, for example, the catalytic cracking of crude oil or the pyrolysis of crude oil, you know, pyrolysis involving higher temperature by burning process, okay, like this in a furnace. Okay, pyrolysis process, too much heat will be applied and this crude oil will be break into several species or several particles, and it will produce a product, for example, diesel fuel. Okay, like that. What else? A lot. We have the kerosene, gasoline, methane, okay, like that, and then a lot. And sometimes the byproducts will produce naphtha, okay, petroleum base, like this. Another byproduct will produce like asphalt, like this, blah, blah. And asphalt is very useful also in the road, okay, but that coming from the crude oil, like this. So that's only the byproduct of crude oil reaction. True pyrolysis reaction, or shall we say catalytic cracking. Cracked, it's being cracked to several, you know, components to produce various products that are useful in our home. For example, the compressed gas, okay, the propane, the butane, the kerosene, the gasoline, okay, like that, blah blah blah, chuba chuchu, okay, like this. It comes from the crude oil originally, something like that. So this that example is not a reversible reaction. That is irreversible reaction, okay, like that. And also combustion is not also reversible. Correct me if I'm wrong. Combustion process, the rapid oxidation of a compound. Because, for example, if you add oxygen, it will produce CO2 and H2. Then if you reverse that one, it will be no longer producing that one. Okay, this. Or else, it could be applicable in the photosynthesis, but I think it's not also. Photosynthesis is not a reversible reaction also. Okay, like that. So by the way, the photosynthesis reaction, okay, the CO2 and H2O is coming from the, you know, the chlorophyll, okay, which coming from the green pigment of the plants. And the CO2 plus H2O will be added oxygen in our environment, we will die. That. And if there's no glucose, there will be no regulation of the blood sugar in our body, right? So it will become a problem for diabetes, something like that. So your sugar in the blood must be controlled, and that's H2Os, 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Imagine that's coming from photosynthesis. It's very important, right? So that's why we need to nurture and care in our environment, because those energy and oxygen we gain is coming from the plants. Okay, like that. And if the plants will die because we abuse our environment, how can we gain energy? Something like that. And how can we gain a very helpful oxygen if our oxygen is already polluted? Something like that. And we will die immediately if the oxygen is very polluted, something like that. Okay, we need to care and nurture our environment that God gave us freely. And we will be responsible enough and disciplined enough to care for our environment. And we need to be an environmentalist in our own self. Okay, even if nobody will push us to that, anybody to, so that's instinct. It will just come in yourself. Okay, that's it. That is very very important. Okay. Oh, my coffee is becoming cold. Oh my God. What's happening? Okay. I was interrupted a while ago, and 39 minutes already. Okay. Okay, thank you so much. The literal principle is very short, right? But it is enjoyable because we will shift here, we will shift here like that. Just like going to the party, where will I go? And here there's less toxic people, I will be here. Something like that in the literal principle. Okay, I will just go here because there are friendly people. There's no friendly people, something like that. So it's gonna be like that also the analogy in literal principle. So if we apply that in the chemical reaction. Okay, so like that. So I hope you gain something with this discussion about Lee Chatelier's principle. If you think you gain and obtain little or few academic information for what I've been discussing, okay, you can like or even comment, okay, or click the notification bell for some news updates of I Am a Singer, Eternal Voice. Or it is better, or it's up to you if you want to share this video to anybody else, okay? Like that. Okay, this is once again, I Am a Singer, Eternal Voice. God bless everybody. Have a good day and see you later. God bless. Bye-bye.